Hi everyone, here are your notes for section 6.3, which is getting us into similar polygons. So what are similar polygons? Similar polygons are polygons having corresponding angles congruent and corresponding sides are proportional. So all of our angles need to be the same measure, but our sides are not going to be the same, because if they were, then that would make them congruent. But our sides are going to be proportional, meaning that each ratio of each corresponding side should be equivalent. Scale factor is the number that describes the change from an original figure to another figure. So if our original figure is getting larger, then the scale factor should probably be a number larger than 1, right? If I was doubling something in size, then my scale factor would be 2. If my scale factor was getting smaller, then it should be some number between 0 and 1. So if I was making it smaller by a half, then my scale factor would be a half. We had congruent statements before in chapter 4. Now we're moving to similarity statements. A similarity statement between two sets of triangles would look like this. Triangle ABC is similar. So it's just the squiggly sign with no equal sign. Remember, the congruent had the equal sign with the squiggle, so here it's just a squiggle. To triangle DEF, if it was any type of shape that had more than 3 sides, then we would just list the letters instead of putting a triangle symbol there. So are the polygons similar? If so, write a similarity statement. So we have 2 questions that we need to ask ourselves in order to determine whether we have similarity or not. So first thing we have to check is, do we have congruent angles? Well, yes, they're all right angles, so that part's good. So now we need to check, do we have proportional sides? Alright, so for proportional sides, we need to compare which sides are proportional with each other. Because you do have rectangles, I would just compare your largest side with a largest side on the other one, so that would be 8 and 14. So I'm going to turn that into a ratio, so 8 and 14. And then I'm going to make a ratio out of the smallest 2 sides, so 6 and 10.5. So now I've got to see, are these guys equal to each other? So there's 2 ways we can do it. Probably the easiest way would just be to divide them. So if I do 8 divided by 14, I get the decimal of 0.5714 and some change. If I do 6 divided by 10.5, I get 0.5714 and some change. So they are equal. So I would say yes. So another way we could have done it is we could have done our cross products. I could have done 6 times 14 and got 84, and then 8 times 10.5 should be 84 too. So 84 equals 84. But me, I just divide it and make sure my decimals are the same. So because they are similar, so yes, similar. Now it says write a similarity statement. So it's not a triangle, so I'm just going to go, I don't know, A, B, D, C is similar to, so I started with A, so K, M, L, J. If I go in order like this is what I did, so then I have to do the same thing over there. All right, for B, are the polygons similar? If so, write a similarity statement. So again, the first thing we need to check are, do we have congruent angles? Yes, I have a single arc, double arc, triple arc, triple arc. So now we got to do the sides. Okay, so now my largest side on the triangle on the left is 12. I'm going to compare that to the largest side over here, which is 9.6. So I'm comparing large to large. I'm going to divide that. So 12 divided by 9.6 is 1.25. Alright, now let's do the middle. Middle, or medium, over middle. So this middle length on the left looks like is 10. The middle on the right is 8. 10 divided by 8 is 1.25. So far so good. So now let's do the smallest. 5 compared with 9.6. Oops. 5 divided by 9.6 is 0.520. Okay, so no, these are not similar to each other. We do not have proportional sides. All three sides would need to be proportional, and they are. Oh, hold on. Oh my goodness. Why did I do 9.6? Go back. 9.6 is not the smallest side over there. It's 4. I was going to say, that does not seem right, which is 1.25. So yes, they are similar. So I'm going to write triangle CAT is similar to, did I set it up to work out? C has a double arc, D has a double arc, A single, O single. I did that on purpose. Okay, there we go. All right, so given the following similarity statement, we've got triangle RST is similar to triangle XYZ. List all the congruent corresponding angles and then a statement of proportionality for the sides. So if I have two similar triangles, then I know that these angles, so angle R would be congruent to angle X, angle S would be congruent to angle Y, and angle T would be congruent to angle Z. Those would be congruent to each other. Now my sides would be proportional. So if I make my first two letters a side, so side RS, that should be proportional with side XY, right there. And then if I do the same thing for the second to last two letters, side YZ should be proportional to, oops, I want to go, I didn't scan out far enough. ST should match up with YZ. So ST, side ST should match up with side YZ. And then my only other side that I'm missing is RT and XZ. So RT would match up with XZ. And these would all need to be equal if it was if they were similar. So this is your statement of proportionality right there. Okay, so your sides are proportional with each other. All right, so in the diagram, we have triangle RST is similar to triangle XYZ. What is the scale factor? So it's getting obviously smaller. So because it's getting smaller, my scale factor, and we usually use a K to represent your scale factor. Your scale factor should be between 0 and 1. So it should be like a fraction. So this is how we do it. All we're going to do is we're going to take a side from the left and a side from the right, doesn't matter which ones, I'm going there, and I'm going to make a fraction. Do I want my fraction to be 30 over 18 or 18 over 30? Which one's going to get me a number smaller than 1? This one. I want my larger number in the denominator. So K is equal to 18 over 30. Always reduce your fraction. I can take out 2 from both of those. That gets me 9 over 15. I can take out 3. So 3 over 5 would be my scale factor. So that triangle is reducing in size by 3/5. And then we need to use similarities and proportions to solve for unknown sides, right? So I'm told that I have similar sides. 12 corresponds with 9. 16 corresponds to 12. So we have to think about, well, what am I multiplying 16 by to get to 12? What am I multiplying 12 by to get to 9? So the easiest way to do that is just to set up a proportion. So watch how easy this is going to be. So I'm going to take this side and this side, since I have both of those. I'm going to turn that into a ratio. 12 over x, and now, or sorry, 12 over 9. Now I need to find my x. Well, x matches up with 20. They're corresponding. They're in the same position. So I'm going to put that as a fraction, 20 over x. And now I'm just going to cross multiply. So this cross product here gets me 12x. This cross product here gets me 180. And then when we do 180 divided by 12, we end up getting x to equal 15. Okay. Could I have gotten there if we did 16 over 12? So 16 over 12 equals 20 over x. Yeah, because it would have been 16x equals 20 times 12, which is 240, divided by 16. It gets you 15 again. Okay, so you're just setting up proportions and solving from there. All right. Oop. So last few, so in the diagram we're given similar polygons. What's the scale factor? Again, it's getting smaller, so I want my fraction to be smaller than 1. So I'm going to put my larger number in the denominator. So here I have a 16 and here I have an 8. Now this one might be a bit more obvious. All right. Maybe crisis averted. I don't know. So 8 over 16 reduces to 1/2, which we could have probably figured that out, right? How do I go from 16 to 8? I take half of it. How do I go from 12 to 6? I take half of it. How do I go from 10 to 5? I take half of it. So if I needed to use that to find the value of x, can you kind of just come up with the answer? If this is x, what do you take half of to get to 4? 8, right? Or you can set up your proportion. So I can do 12 over 6, because they're corresponding, is equal to x over 4, which gets us 6x equals 48, so x is equal to 8. Or you could have done 16 over 8 equals x over 4. Or you could have done 10 over 5 equals x over 4. Or you could have done 2 over 1 equals x over 4. All right, and last example, we're told that AB is proportional. Remember, this symbol right here is just another sign for a proportion. So I can rewrite this as a fraction of AB over BC. Is another word for equals, and then I can rewrite 3 to 4 as a fraction of 3 over 4. What is the length of AB? It's 6. We need to find BC, so BC is really my x, is equal to 3 over 4. Cross multiply that gets you 3x equals 24, so x is equal to 8. All right, that concludes your notes.